The Pythagorean Theorem by Monica Chudnowsky. In mathematics, the Pythagorean theorem, or Pythagoras' theorem, is a fundamental relation in Euclidean geometry between the three sides of a right triangle. It states that the area of the square whose side is the hypotenuse, which is the side opposite of the right angle, is equal to the sum of the areas of the squares on the other two sides. The theorem can be written as an equation relating the lengths of the sides A, B, and the hypotenuse, which is side C. The Pythagorean theorem is largely credited to the Greek mathematician Pythagoras of Samos during sometime around the 6th century BCE. It is named after him because he wrote the first known proof which spread throughout the world. It is said that Pythagoras discovered his theorem in a palace hall. He studied the stone square tiles when he was bored and pictured right triangles within the tiling. He recognized the area of the squares on the side lengths were equal to the square on the hypotenuse. From this observation, he believed that the same would be true for right triangles of unequal side lengths. Although the theorem has long been associated with the philosopher Pythagoras, it is actually far older. One of the earliest recorded uses of the Pythagorean theorem, or the idea of it, was in Egyptian hieroglyphics. Some Egyptian workers constructed a tool which formed right triangles by measuring the distance of each side of the triangle. This was done primarily by the 3-4-5 rule, the converse of the theorem for a special case. The device consisted of a rope with 12 equally spaced knots and made a triangle of side lengths 3, 4, and 5. Their goal was to form a right triangle with the knotted rope and machine. From the known side lengths and the special case of the Pythagorean theorem, they guaranteed a triangle with a 90-degree angle. Although it was not a proof of the theorem, the Egyptians recorded the earliest known application of it by displaying a hieroglyphic image of their work. Although they used an application of Pythagoras' theorem to create right triangles, it is unclear whether or not the Egyptians knew anything about the theorem when developing their workman's rope. The Pythagorean theorem is considered proven once, but due to its fundamental nature in geometry, mathematicians have developed hundreds of different proofs for it over the years, meaning new proofs are occasionally presented, with some estimates stating there are over 300 known proofs of the theorem. Here is an example of a visual proof showing the squares of the sides. Notice how one side of the right triangle has a total of 16 squares in it, and if you add the other side of the right triangle, which has 9 squares in it, this yields the result of 25 squares for the hypotenuse side, which proves the Pythagorean theorem true. To understand the Pythagorean theorem, you must understand right triangles. A right-angled triangle is a type of triangle that has one of its angles equal to 90 degrees. The sides that include the right angle are perpendicular in the base of the triangle. The third side is called the hypotenuse, which is the longest side of all three sides. Using the Pythagorean theorem is fairly easy. First, find the two legs of the triangle that meet to make the right angle. Then, identify the side that is opposite from the right angle, and this is going to be the hypotenuse. Lastly, take the Pythagorean theorem and substitute the two legs into the equation and solve for the missing length, which is the hypotenuse. Now, let's use the Pythagorean theorem equation and solve for a right triangle. Let's say we have a right triangle with two legs and a hypotenuse. We are given the lengths of the two legs, but not the length of the hypotenuse. So we can use the Pythagorean theorem to find the hypotenuse. The two legs are labeled leg A and leg B. Leg A's length is 7 inches and leg B's length is 24 inches. Now let's take 7 and 24 and plug them into the equation where A and B are. This gives us the equation of 7 squared plus 24 squared equals c squared. Let's solve for 7 squared and 24 squared. So 7 squared is 49 and 24 squared is 576. Now the equation states 49 plus 576 equals c squared. The next step is to add the two known numbers together. So we will add 49 and 576 together, and this equals 625. Our equation now states that 625 equals c squared. Finally, to solve for c, we have to remove the squared sign from c. So to do this, we will take the square root of 625. The square root of 625 is 25. So now we are left with our answer, which states that 25 equals c. So our hypotenuse length is equal to 25 inches. The Pythagorean theorem has many real-world applications. It can be used in different ways to find different lengths, amounts, distances, and percentages. People are constantly finding new ways to incorporate the Pythagorean theorem in their daily lives. One way people can use the theorem is in building and architecture. By applying the theorem, people can create accurate and safe designs that ensure that elements are properly aligned and measured. The Pythagorean theorem not only helps in the construction process, but also ensures the final structure is stable and aesthetically pleasing. It can be used to ensure right angles when constructing walls. It can verify square corners, determine roof slopes. It can measure the angle of stairs and identify heights of buildings. Another use for the Pythagorean theorem is in navigation and GPS. It can provide accurate distance measurements, efficient route planning, and precise location tracking, making travel safer and more efficient. People can use it to calculate the straight line distance between locations by treating the distance as a hypotenuse of a right triangle. The theorem can also be used to calculate distances between satellites and receivers. It's also useful to find the shortest distance to a location. One more example of the Pythagorean theorem being used in everyday life is in games and sports. By applying it, athletes, coaches, and gamers can make more informed decisions, improve strategies, and enhance performance in both physical and virtual arenas. It is most commonly used in sports analytics to calculate a team's expected winning percentage based on the points they scored and allowed, essentially estimating how many games they should have won, often referred to as the Pythagorean winning percentage. The Pythagorean theorem helps us figure out the relationship between the sides of a right triangle. This theorem is super useful because it lets you find the length of one side if you know the lengths of the other two sides. You can use it in real-life situations like measuring distances or building things. Thank you.